Right. Last day we were discussing about the searching algorithms, and today, so I need to give you an idea about sorting algorithm. So basically, here in this sorting algorithm, mainly in the examination, what they focus is about this bubble sort. And that doesn't mean that other sorts are not there. Yes, other sorts are also there, but mainly in the examination, bubble sort is given more priority, but the other sorts are also considered. So this is for unsorted list, right? This is for unsorted list. And then, so let's see what's this bubble sort. So in the bubble sort, mainly consider about adjacent elements. It's considered about the adjacent elements. In these adjacent elements, so what happens in this adjacent element, it will compare the right side and the left side element. So let's say the right side element is greater than the left side element. If right side element is greater than the left side element, it keeps as it is. But in case something like this, let's say the right side element is less than the left side element, then it swaps, it interchanging like this. The position of 38 will be moved forward and the 48 will be come back. So, okay, let's say the first instance, 3 and 44. You can say 44 is bigger, no need to swap. Then comparing 44 and 38. Now you can see 44 is bigger. So you need to swap. So 44 will come here and 38 will go here. Then the 48 and 5. And 44 and 5. So 5 is less than, so 5 will come here and 44 will go here. Likewise, it will complete a round. Let's see the animation to understand this more. And let's start. Okay, let's start. So, okay, you can see swapping happens when the right side element is smaller. Right small swap, right small swap, right bigger, right small swap. Okay, you can see the first round. End of the first round, the largest element will go to the corner. At the end of the first round, the largest element will go to the corner. Let's start from the beginning. This was the list. The comparison happened between the adjacent elements. And if the right side element is smaller, then the swapping happens. Here, left element, right element. If right element is smaller, the swapping happens. Otherwise, no swap. Okay, let's play it again. Okay, swapping happens, no swap, swapping happens, swapping happens, swapping happens, swapping happens, swapping again, swapping again, swapping again, swapping again, no swapping, again swapping. You can see this is the first round. Again, the second round. The second round, as a result, the second largest element will move to the corner. This is the second. And in the third round, the third large element will move to the corner. Okay, in the fourth round, the fourth large element will be go to the corner. Then the fifth round. So this will continue to happen. This will continue to happen. And as a result of this, what will happen when you finish? Okay. But still not sorted. Okay, finish sorting. Now it compares. When there are no swaps, it will stop. When there are no swaps, it knows that. So yes, if swaps are over, right, if no swaps, so initially you can say swaps false. So if no swaps, while swaps, if swaps are there, it will continue, but no swaps, it will stop. That means already sorted. Okay, let's start writing this as an algorithm now. Right. I'm going to start my ideally. Take a new file. Okay, so the easiest thing is you can see here the pseudocode is given. Pseudocode is given. So I'll give you like 2 minutes or 3 minutes. So can you try to write a Python code quickly? So looking at this pseudocode, right? Because pseudocode is already given. By looking at the pseudocode, can you try to write one alone? Just take maybe 2 minutes, 3 minutes and do this. I think it's easy because the conversion can be done easily because algorithm is there. Only need to write in Python syntax. That's all. Take it, Ritum, basically it's like this. So you can, so here actually start doing this. You can say, so let's convert the same. So I'm doing like this, like while 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 true. I'm starting doing. So while true means it's always happening, right? So what? Swap equal false. So then swap false. And then for I in range, you can say 1, starting from 1. Index of last sorted element, like you can say length of the list minus 1. Length of the list minus 1. Actually, this is a function, right? You have to write this as a function. Def bubble sort, BBL sort. Bubble sort, the list is here, and this list you are going to sort. Then while true, swap false for I in range in. So here list, let's say LST, right? This list is a keyword. Let's say LST. List is a keyword, otherwise it will give wrong answer. Okay. For I in range, this. Then what? If the left element, so how to find the left elements? That can be done is in I is the left element, or you can say LSTI is greater than LST. You can say I plus 1. The right element is always 1 more than the left element, right? 1 index more than the left element. So you can give LSTI and greater than here LSTI plus 1. So you can just do that. Then okay, if ls left element, right element, okay, good. Then swapping can be done, the left right swapping. So that can be done like this. There is a special method in Python to do that. So this is only working in Python, right? You are make it equal. So this LST I plus 1 will be equal to this one, and same time LST I plus 1 is this. That means the value of I. So value of I will be the right element. Value of I plus 1 or the right element will be the left element. So this only works in Python. So remember that this only works in Python. Okay, so let's move to the next one. So after that, you can say swap equal true and swap counter. What is swap counter? Swap counter, it's not really okay. Swap count is not required. I don't know why it's used. Swap count, is it somewhere? So no. Okay, let's keep it as it is, and I'm just saying swap equal true. Once swapping happens, I'm just telling swap equal to, once swapping happens, swap equal true. Then so here while swap, here there's a condition. that condition indicates, that's condition indicates, and while true is can, except while except if, while true. Okay, this happens at false and on. So this continue if sapin happen. This continue if sapin happens. You can say, okay, you can break it, right? You can break it here if sap equal false. You can break it. No saps, then break. Okay, let's run the code now. Let's run the code now. Okay, you can see it's running and no errors. So let's give a list. My LST or LST is equal to some list. So small list and then bubble sort the list. Okay, then print in the LST and you can see it's not sorted. Okay, it's not sorted. So this sapin happen and sap true. If sap equal to false, sap true, and this happens continuous, and after that, okay, let's print something. I just want to print swap. Oh, sorry. So only one swap happens. What is the list? This print in swap. So let's the I and I plus one. I plus one I. Okay, that has happened. So why is that? Then I'm going to print in LST again. So why it's not printed? It happens only for the last elements, that seems, right? Okay, just give. Okay, then this happened only for the last element. You can see 34. This has set, not for the first element. So some we are starting from 1. Sorry, it's my mistake. We have to start from 0. Right, that's primitive mistake. The basic thing, lists are 0 indexed. The list are 0 indexed, so you have to start like this. And 2 saps happen. And let's say now I'm printing the list and should print. Okay, now you can see it's printed. 2 times swapping happens and those swapping related to. Okay, so how rounds you can count, how many rounds this happened also you can count. In each round you can print round, 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 and I, and let's keep the I here, I equals 0, and each round, so when you go here you have to include I equal I plus 1, and finally print in I here. So let's see this now. Then we can see how many rounds it need to sort. This is my list and this is the bubble sort. And what's this str? All right, okay, str the I. Okay, these are some additional things, right? These are some additional things. You have the list and the bubble sorted list, and then here you can see, so it's printing 3 rounds, right? Basically 3 rounds. The first round, I think. So let's write this. So let's write this and understand. So that is the easiest way of understanding this. Okay, here it is. This is first round. In the first round, 23, 4 will sap and 4 will come here. Then 23 will go there, 4 and 23. Then 23, 56, no sap, 56, 34, there is a sap. So 54 will go there, 56 will go there. Okay, the first round. The second round, so I equal I plus 1. I is initially 0, I equal I plus 1. Then the second round. Second round comes here. The first round, you compare no need to sap, compare no need to sap, compare no need to sap. So count in I again. So I will be 2 now. So it's printing 2. Right, printing 2. But you can see no saps here. No saps here. Sap equal true here. Okay, for I in range, right? Okay, no saps. If sap equal false, break. Is this happening? So I just want to print another thing just to check. Print breaking. Is it happening? Or is it naturally going to be finished, or is it going to be break? Yes, breaking. It's breaking. That sap become false and it breaks. That happens in the third round. Yeah. First round sap in happens. The second round check in. The third round it breaks. Yes, third round it breaks. Yeah, that is true. First round sap in happens. Go back. Second round. Yeah, that is also sap in happen. Again, third round breaks. Okay, so now no need to write down these things and no need to write down this even. So we have the algorithm and we need to test this multiple times, right? So let's check for some other list. I'm running it again, and finally you can print this, right? Finally you can print this. How after all these things, before breaking, you can print the LST. That can be done. So let's run it again. And now I'm going to give a long list, LST or long list, let's say marks. And my marks, I'm going to enter 23, some marks. A long list of marks, and I just need to bubble sort those marks. Bubble sort those marks. MARKS and okay. So you can see there are 11 rounds, right? With 11 rounds, the sorting happens. With 11 rounds, sorting happens. Are we printing the round? Yeah, we're printing round here, right? Each time the while loop runs, the round is printed. I equal I plus 1. Yeah, each round, each time this happens, will be print. Swap in happens, then it will not be printed, right? In swap in also need to be print. So you can include this here, but yeah, no need. So just you can ignore this part also. This is also not needed. But anyway, the result should be the sorted list. Now here's the marks, and I'm sorting the marks, and I'm getting sorted marks. That's all. And I wrote the algorithm according to. Okay, SAPIN can happen some other way also. In the examination, this can also be tested. SAPIN වෙන්න පුළුවන් තව විදියකට. Exam එකේ මේක test කරන්නත් පුළුවන්. SAPIN can happen this way. So let's say you have a coffee mug, a tea mug. So coffee and tea. So let's say this mug is filled with coffee and there's another mug. So that mug is tea. It filled with tea. So let's assume like this. If you want to put tea into coffee mug and coffee into tea mug, so the solution is take another mug. Take another mug. So this is a temporary mug. So let's blow that in another color. This is a temporary mug. So what you can do is you can put, first of all, you can put tea into this mug, then put coffee into this mug, and now you can put tea into this mug. Step one is this. ඉස්සලම කරන්නේ මේක empty කරගන්නවා. මේ temporary mug එකට දාලා. Step 2 එකේදී empty වුණාට පස්සේ අනිත් එකෙන් fill කරනවා. Step 2 is this. And step 3 is you put the temporary mark content to the other mark. That is step 3. So this can be done. This is another way of sapping. මේක තමයි standard way එක. This is the standard way of sapping. Okay, that can be done like this. You can start like this. That can be done this way. So you can say TMP equal this, and you can then tell this equal this, and finally you can tell I minus 1 is equal to 10. That is another way of swapping. That is also okay, but that is too lengthy. In the examination, both can be tested. So see here, still I'm getting the results without any error. Still I'm getting it without any error, because this way of swapping is also accepted in the examination. So either this way, or you know the short way. The short method is you can give, this is the short method. I'm going to comment it. This is the short way which can be used in Python, right? Please write down this. This is swapping example. I'm just showing that. Please write down this as the example. Write down the code. We need to learn 2 more. So basically this one will be asked in the examination, right? We'll discuss with the exam questions more. This one will be asked in the examination. The text is insertion selection sort. Okay, selection sort. In selection sort, basically it's very simple algorithm. In the selection sort, what is considered, so finding the minimum or finding the maximum and swapping that minimum or maximum with the last element or the first element. Okay, let's say the first round. So it is possible when I run this, you can see start sorting. It will first go and find the minimum. Okay, 38 is the minimum, 8 is the minimum. Likewise, it will compare all other elements, and now 6 will become the minimum. Okay, after finding the minimum will be swapped with the first item. Then the next minimum. That will swap with the next item. Likewise, it's always, or this can be done another way also, finding the maximum and swapping it. Find the minimum and swapping it, or finding the maximum and swapping it. Both ways you can write, right? In both ways you can write selection sort, which is easy algorithm. But the effort taken so is quite big, right? So earlier one just swapping the element. This one is just searching the minimum, swapping it, and then right. You can see it's continue to do the same. Continues to do the same means finding the minimum and swapping. Okay, after all the minimums are found, the job is over. After all the minimums are found, the job is over. Okay, let's write the code now. So this is less popular than the bubble sort, but still the sorting algorithm is both sorting algorithms. So both sorting algorithms are having issues. Issues means like it's not issue, but those are expensive. Expensive means you can see number of rounds. So this can be n rounds, right? N rounds. Round n gana can n means number of items. N rounds are So maximum, in the worst case, there can be n round. And each rounds, there can be n number of comparisons. So we explain complexity of this algorithm as n into n. Or big O notation, n squared. The complexity of algorithm is O(n) squared. Why? There will be n items. So basically n minus 1 number of calculations. Right? If there are 1 million elements in bubble sort, there will be n minus 1 comparisons and n minus 1 rounds will be executed. So altogether, so let's ignore 1 since 1 is small. Let's ignore 1. So n into n is n squared. So this is really, really expensive. N vargaya, hitan udak වැඩි. So really expensive. Okay, then this is same for, right? This is same for the selection sort. It is same for the insertion sort, but there is small difference in the insertion sort. So let's learn that. Okay, please write down this. This is the algorithm related to the selection sort. Please write down this selection sort algorithm, and what I have done, finding the minimum and swapping the minimum with the first element or the next first element, next element, next element, keep swapping the element, and finally it will be sorted. I'll explain this with the code. First of all, please write down this selection sort. Let me explain the algorithm. So here, so this can be done in multiple ways, right? You can see. So this is a list, and in this list, you find in one thing is finding the minimum and bringing that to the beginning. Finding the minimum and bringing that to the beginning will sort the list in ascending order. Then finding the minimum and bringing that to the end. Actually, moving that to the end will sort in descending order. Descending. Then finding the max, bring to the front, descending. Finding the max, then move to the end, right? Find the max, move to the end. So that is ascending order. So these are possible ways of sorting in selection sorts. Here in the first one, what I'm going to do is the minimum element will be the first element. So that is 3, right? With this, I am comparing the other element. If something is less than 3, no, not less than, not less than, not less than. Okay, 2 is less than. So then that will become the minimum. So then the next minimum will be so then the 2 and 3 will be set. Then the next minimum will be 44. You compare with 44. 44 is the minimum? No. So 44 and 38, then 38 will become the minimum. 38 and 5, then 5 will become the minimum. And 5 will remain. And when you go to here, 3 will become the minimum, and 3 will and 44 will be set. Right? You saw how it happens in graphically. What will happen? So when I start moving, so it will first find the first minimum. Blindly ගන්නකොට පළවෙනි element එක minimum කියලා ගන්නවා, because we don't have other way of comparing. No? So if there is only one element, that will be considered as the minimum element. And the next minimum will be found, and minimum will be swapped with the 38, And the next minimum will be found, okay, 29 for the movement, 14 for the movement, 9 for the movement, and 9 and 8 for the movement. Okay, now 8 will be swapped with 44. Okay, that is the algorithm. Okay, that is also having big O(n) squared complexity, because that is also not that much healthy. But when it comes to insertion sort, so that is bit less expensive. Bubble sort, selection sort, both are expensive. Expensive means it has more operations, comparisons, more sorting. So there are more. But when it comes to bubbles insertion sort, so that is quite better than previous to Y. So in this sort, the idea is just dividing this into 2 sublists, left and right. Dividing this to 2 sublists, left and right. Then after dividing, they try to insert the element to the right position. So here it's inserting, it's finding the position, then inserting into the correct position, right? So for an example, okay, let's start from the beginning. Let's start from the beginning. Inserting into the correct position, you can see. You can see, so this orange color one is your left set of the list, left side of the list, and the right side of the list is this. So it's when item is picked from the right side and insert into the correct position. So this is one time in one round, everything will be inserted. It's not going to multiple rounds. That is the advantage, but there will be more comparisons, but just within one round, the sorting will happen. Sorting. So the complexity will be little less than the previous two. This complexity will be little less than previous two. Cannot say it is not expensive, it is still expensive, but less than previous two. Element එක හරි තැනට insert කරනවා. That's only. Okay, now let's see the coding related to this. And you can see the left and right. So please write all the steps. So in insertion set, 2 is taken and 2 is inserted to the correct question. Then 45 is taken, insert into the correct question. So this is what repeatedly happened. And the code is also given, so you can write down that. Right. Okay, these are the 3 ways of sorting a list. Right. Search in algorithm, actually, we have already discussed sequential and binary search algorithm that we have already discussed. Then under this lesson, so yes, we discussed everything. Yeah. Now, actually, we have to do the database part. That is what remain in here. So that we need to do with PHP also. Therefore, I'm not going to do that now. So database with Python. So that part I'll do after finishing the database lesson. Okay, I'll stop with this. And next day I'll be discussing a new chapter. Right, I'll be discussing a new chapter. Let's see whether we can discuss operating system or the other subject. So let's see. I'll let you know that I will do next day, right? Okay, then good night.
Thank you, sir. Good night.